Hey, hello, fellow owner-operators and backyard mechanics. Slavka Alabamka is back with more repairs. Today we're going to service this Detroit diesel AC compressor pump. As you can see, my AC compressor pump is basically failing. It's leaking oil out of the seal shaft there, and it's coming out of here. So it's going to, pretty soon it's going to seize up. It's leaking out coolant, so we're going to have to replace it. Got a good life out of it, about 18,000 hours, 560,000 miles on this compressor, so it performed well. Today we're going to repair it and replace it. So before we do that, let's take a look at the kind of tools we're going to need. We're going to need a manifold gauge set, a vacuum pump, your basic set of breaker bars, like 1/2 inch with some extensions in the socket set, a refrigerant. The truck is using 3.8 pounds of refrigerant, so that's roughly 5.5 cans. So I got 5.5 12-ounce cans, so I got 6. And we have the new compressor here, and I'll have the parts and part numbers and links below in the video, so you can just reference that if you ever do this job. It's pretty much identical process for all the DD15, DD16, and DD13 engines at the Detroit diesel line. But it will be also similar on Volvo, you know, slightly different, probably ports and outlets, but I mean, the principle is the same. So we're gonna do step-by-step compressor replacement guide. So let's start off with our manifold set, and we're just looking at the high side and low side pressures. As you can see, my refrigerant pretty much leaked out, so that we don't have to evacuate it and store it. But if you're doing the service with still pressure remaining in your system, you got to pump it out and store it in some kind of container that's rated for your refrigerant. It's R134 in my case, but at this point it's vented to the atmosphere, so we're gonna go ahead and crack it open. But needless to say, you need to make sure there's no pressure in there. Once we start taking bolts off, you don't want that shit going in your face. By the way, your connection ports could be in different locations, but generally, if you follow lines coming out of compressor, the low side is blue, it's fatter, and then the high side is narrower. You can't mix it up. Sometimes on some trucks I see them somewhere up there by the expansion valve. Sometimes they're somewhere on this side, usually on the passenger side in most trucks. But you're gonna have to locate those, connect them, make sure they're seated and everything's reading correctly, so you can see the pressures. But yeah, we're gonna go ahead and at this point take off the charge air pipe from the coming out of the turbo, just to get it out of the way, because it'll be easier to reach in there. And I'll see you after I take that off. So we're just taking this pipe out. All right, so with CAC pipe out of the way, we have much better access to all the workings here. So I'm gonna go ahead and disconnect all these sensors, high side pressure switch and the sensor, and then I'm going to disconnect the clutch, the solenoid clutch for the AC compressor right there. Just got to cut the zip tie, and then we're going to pop off. We're going to undo this nut right here, and we're going to take out, basically free up these low side, high side pipes out of the compressor itself. All right, with these seat lines out of the way and clutch solenoid disconnected from the truck, next step, we got to free up the serpentine belt. So the way you do it, take a long socket or breaker bar with a 1/2 inch breaker bar with a 5-inch extension, and place it in the slot for the second roller on the belt tensioner assembly, and just simply push it down like this. So you push the rollers down, that creates slack, and we take the belt off. So we push it down, create some slack, and grab the belt and just pull it aside. There we go, that's all we need, and then we can relax it. And we free up the compressor from the engine by using a 1/2 inch socket. And there are 3 bolts, 2 on the bottom, 1 on the top towards the pulley. right there. And here's our old compressor. This is the bottom side. You can see where it's been puking oil, and just everything's mixed in there. It's definitely in the bad shape. And if you don't take care of it, if you just let it run without oil, it's going to seize up and potentially get your belts thrown, and you're going to have a lot more problems, and there's going to be a breakdown. Even in the winter, when you put defrost on, for example, on your windows in the cold weather, your AC is working to remove the moisture, so you actually need it in the winter just as much as you do in the summer. It's not the matter of comfort as much as safety, but yeah. And here's the new one. So they're around, this is original OEM, so I'm not using aftermarket. They're around $503 or so at the dealers or parts stores around here in southern Alabama. Some online places advertise them for 300 some bucks, 257. Those are all aftermarket. I cannot say anything about them. I never use them. I always put original parts. So yeah, so I'll have the link for the compressor to my trusted Amazon seller that I always buy parts from. So we'll have the links for these parts and part numbers, everything listed below in the video. Alright, we got new compressor fitted, and it's pretty much ready to be reconnected. So one thing I want to mention, well actually it's a couple things. This compressor came pre-filled with a compressor oil. If the one you get does not have it, you have to have this kind of lubricant, usually PAG 46. And you're gonna have to download the instruction manual or data sheet for your compressor when you get it, and figure out how many ounces of oil. It's absolutely critical to have correct amount, because if you put too much, it could actually create a hydrolock in there. It's too much oil, so the refrigerant has nowhere to go. Too little, and well, you're not going to have sufficient lubrication. It's just going to burn up. Another thing I want to mention, when replacing the compressor, you also should replace the dryer. Now, in my case, this dryer has been recently replaced, and it was part of a problem I was trying to diagnose with my weak AC, but it turned out to be a compressor. But at the time, I did not see the leak, so I replaced the dryer, replaced the expansion valves just a month prior, so I'm not going to do that right now. So I'm going to go ahead. Oh, by the way, one more thing. When torquing this down, these bolts, I don't have exact foot-pound specifications, but my advice, use a small socket driver and just hand snug. Do not use big ones or any kind of breaker bars. There's a soft aluminum brackets in there, and if you start putting too much torque on it, which it doesn't need, you will simply strip the bolts out. And that goes for your alternator and belt tensioner assembly. So just be careful. As insurance policy, I use a small hand socket driver. That way there's no way I can over torque it. There's just not won't have physically enough strength to do it. All right, we got compressor mounted, reconnected our low pressure, high pressure lines. We got our clutch wire connected. So we're just gonna put the belt on, same way we took it off. We're gonna release the tension on the tensioner assembly and bring the belt right over the grooves and let it gently go. Now we can extract our socket driver, breaker bar. That's it. That's the trick with a belt tensioner on these Detroit diesels. So we got our compressor all mounted, connected. Before we put the CAC pipe back in and start charging it, we need to pull the vacuum. We need to evacuate any air that's left in the system, and we need to basically make sure that any kind of residual atmospheric moisture, anything, is evaporated. So the way that happens is we connect both high side and low side, open both valves, high side and low side, and then turn on our vacuum pump. So while the vacuum pump is running, we're going to slowly start seeing the gauge go into negative territory. We know we have a good seal. Once that builds up, here I'm going to open this valve, and this one's open. We're going to leave the pump running like this for about half an hour, and that's just to ensure that the moisture, any kind of water vapor, is all removed from the system. And we're going to monitor that gauge, make sure the vacuum actually holding. That would confirm that we have no leaks. So I'm just going to let this pump run here for half an hour, and then I'll turn it off, and I'll keep watching the manifold gauges to make sure we're not having air coming back in. If we do, we got to fix that before we go on next step, charging the system. It's been about 15 minutes of vacuum pump. I'm still running it, but I'm seeing promising results here. We're already seeing basically negative 30 inches of mercury on the low side, and almost like 28, 29 on the high side. That gauge is slightly off, it's not calibrated, but they both basically should be same vacuum. So we're just gonna let it run. Like I said, that allows time for the moisture, any kind of moisture that's gotten in the lines and an evaporator and a condenser. It allows it to evaporate the very low air pressures, and in essence causes water to boil at the room temperature. So that's what we're doing. This has been about half an hour. We've been running this vacuum pump, so the pressure is pretty much stabilized, and we're holding 30 inches of mercury vacuum stably. So I'm going to go ahead and close off the valves, both high and low side. So now the system's isolated, and we can turn the pump off. It's basically just gonna sit and wait and make sure we have no leaks. If we have air leaks, the vacuum will reduce and it'll go back to zero. The pressure outside and inside will equalize. So we're gonna give it another half an hour at this point, just to confirm that we have good vacuum, good seal. So it's been about half an hour. As you can see, we still have perfect vacuum. That means we have a good seal. The vacuum's holding. That means the refrigerant's not going to be escaping somewhere. So in the meantime, I replaced the charged air cooler pipe, or aka CAC pipe. So the next step, we're going to start charging the system with the refrigerant. So the refrigerant type we use for most of modern vehicles now is R134A. Typical, you can find in Walmart, anywhere really. It's about $6 a 12-ounce can. Each truck's going to have somewhere a label like this, and they'll tell you how much of refrigerant you need. In my case, it's 3.88 pounds, which roughly translates to 5.5 of these cans. And I've purchased 6 of them, so because obviously we can't have half a can. And as I'm charging it, you'll see the process of charging, and I'll show you how to know when to stop. You can watch these pressures and you know when the system is fully charged. So I'm getting ready to charge. I got both valves closed off at this point. I have removed the vacuum pump, and I've put this tap adapter to go on top of the charge can. So we'll screw this on and then turn the valve, and it will depress or puncture the membrane there, and then we'll have refrigerant going in the charge pipe. Now, the way you do it, right now we have vacuum in the system. So the first can we're gonna put in, we're not gonna start the engine. What I'm gonna do is I'm gonna connect the can to the charge hose and open up the low side and let the gas go in on its own, since we have the vacuum, until the pressure stabilizes. After that, I'm gonna go start the truck and turn the AC on both bunk and the front on the dashboard to maximum. And while the engine's running, we're gonna only use the low side at this point. Never open the high side, because it'll blow in your face. I'll put high pressure right back in the can, and I can't handle that. So we're gonna use low side to slowly ingest 5 cans. On the 6th can, I only have to put a few ounces, so we're gonna watch the gauge closely, and we will see the pressure start rising on the low side when going to stop. All right, so now we got the engine on, and made sure the AC clutch is engaged, so it's spinning the pump, and we're slowly adding refrigerant. We have the low side port open valve right here, high side closed, and we are watching in the sight glass, making sure we don't flood it with too much refrigerant. System's already accepting refrigerant. I can feel it's cooling off. We got to keep adding cans. Like I said, we got to do 5.5 cans here, and we're carefully watching the low side pressure. Once it starts spiking, you know you got plenty. So high side should not exceed about 300, but it varies on the temperature. Right now it's about 72 degrees outside, so it should not get more than 200. Alright, so we're carefully adding last can. We gotta watch the pressures, and we're watching the clutch cycling. The low side pressure has to stay below 50 psi but above 30. So we're right about the sweet spot, the point right now. Just waiting for the clutch to cycle. So there it goes. Pressure's dropping like expected. It's the suction side. This should about do it. And we're in the cab now, and we're getting nice frosty, steady, cold air, both from front dashboard and back in the sleeper. So just gonna let the truck run for about half an hour, and gonna check the pressures, but everything seems to be working well. There's no excessive cycling, and pressure's within the limits, so that's how you do it. That's how you change the compressor in DD15 engines. It's Freightliners, Western Stars. The process is similar from most truck manufacturers with slight variations, but the basic principle is the same. So with that, thank you for watching, and I will have the part numbers and links to the parts I used in this video available below in the video description. Good luck with your repairs.